Hey there, this is Mathcamp321, and this is another installment of a video series on logarithms. This particular video is part 7 and discusses natural logs. Recall that an irrational number is a number that cannot be expressed as the ratio of two integers. Two examples of irrational numbers would be the square root of 5 and pi. Another frequently used irrational number is the number e. E is approximately 2.718. To access the E button on the TI calculator, you press second and then the division button. Find and press the E button on your calculator to actually see the decimal 2.718. You might recall from prior videos on logs that the base can be any positive number. Many times though, the base is going to be this new number e. And when that is the case, we're going to use a special notation, ln. ln stands for natural log, and it is used specifically in the case when the base is e. As an example, if you wanted to say log 1 base e, you would actually write ln1, or the natural log of 1. As a second example, if you wanted to write the log of e base e, you would actually write ln e, or the natural log of e. So basically, if you're ever working with a log and the base is e, you're actually not going to write the word log, but you're going to write the letters ln, which stands for natural log. At this time, I can share with you another way to access the E button. You can also access the E button by pressing second and then the button that says ln on it. The ln button is next to the number 4 button. At this time, I'd like you to use your calculator to evaluate the natural log of 23 to 3 decimal places. I'll give you a moment to do that. Your calculator should reveal that the ln, or the natural log of 23, is 3.135. Next, I'd like you to use your calculator to evaluate the natural log of 0. I'll give you a moment to do that. As you probably may have discovered, you're going to get an error message. A concept that I'd like to reinforce from prior videos is that the argument of a log needs to be positive. The same holds true for natural log expressions. The argument of a natural log expression must be positive. Let's move on to the next slide. Most of the skills learned in the common log videos can be applied to natural logs as well. Part 1, conversion. Convert from natural logarithmic form to exponential form. If you recall, we called this a swing. Number 1, the natural log of 1 equals 0. Because our expression is in natural log, we know that there is an implied base of e. So I'm going to go ahead and write that in. In doing the swing, we'll start at that small base e. We'll swing up to the right, and then we'll land on the number 1. This will yield an equivalent exponential form of e to the power of 0 equals 1. And of course that's true. Let's go to number 2, which says ln of e squared is equal to 2. Recalling that there's an implied base of e, which I'll go ahead and write in, and doing the swing, we'll start at that little e, we'll swing up to the right, and then we'll land on e squared. This will yield the equivalent exponential form of e squared equals e squared. And of course, this is also true. Let's reverse the direction and go from exponential form to natural logarithmic form. Remember, the trick in doing that is to focus on your base. In this case, the base is e, which means I'm going to use ln notation. So I'm going to end up getting the natural log of e to the 5th is equal to 5. Many students are less confident with unswinging than they are with swinging. So what I always suggest to my students is, after you take a stab at it, after you take a guess, to actually swing and see if it checks out. So if we did a swing, we'd put that base of e in there, and then we would just start at that little base, swing up to the right, and land on our argument. And this would yield e to the power of 5 equals e to the power of 5, which of course is true. Let's move to the last example of this slide. Once again, we have our base of e, and because that base is e, we're going to use natural log notation as opposed to common log notation. and we're going to get the natural log of e is equal to 1. And again, as a check, I'll go ahead and I'll put that base in there and I'll do a swing just to see that we get what we started with, which would be e to the power of 1 is equal to e. And that's exactly what we started with, so we know we're okay. Let's go on to the next slide. So on our last slide we talked about conversion and realized that the method was the same whether for common log or for natural log or any old log. In part 2 we're going to be talking about the 3 properties of natural logs, and you'll notice right away that they're identical practically to the rules for logs that we did in a prior video. In the product rule, if you're taking the natural log of a product, you end up getting ln of a plus the ln of b. If you're doing the quotient rule for natural logs, the natural log of a divided by b, you end up getting the natural log of a minus the natural log of b. And if you're applying the power rule to a natural log, the natural log of a to some power n, you end up getting n natural log of a. To convince yourselves that these properties actually hold true for natural logs, I've given you basically the same examples as on the properties video a few videos back. So I'd like you to get your calculator out and find the decimal equivalents on each side of the equation. So in other words, I'd like you to test on your calculator the natural log of 20 versus the natural log of 4 plus the natural log of 5. So I'll give you a moment to do that. In doing these two calculations, you should conclude that the results are the same on both sides. Let's move to ln of 6 is equal to the ln of 18 minus the ln of 3. In doing these calculations, you should conclude that both sides are the same, being 1.791. And finally, let's go to number 7, where we're going to convince ourselves of the Power Ranger rule. The natural log of 49 is equal to 2 ln 7. And again, both sides end up being the same exact thing. In a moment, we're going to switch to a new slide, which we will expand and condense natural logs and use these properties throughout.